All right, so today it's a real pleasure to have Dr. Sarah Cooley, who is the director of the NOAA Ocean Acidification Program, a position that she's only recently taken on. And Dr. Cooley got her PhD in marine science from the University of Georgia. She spent time at the Woods Hole Oceanographic Institution as a postdoc and a researcher. And then she went to Ocean Conservancy for quite a while and did a lot of interesting work at Ocean Conservancy and including being involved with the IPCC reports. And those are, that they are a real beast, if I could put it that way, and they require a lot of time and dedication. And thanks to people like Dr. Cooley, those reports are looked at as a very credible source of information about climate and climate change and research around climate change. Dr. Cooley, through her various jobs and interactions, is very good at science communication and has done a good job in communicating science and policy to a whole range of audiences. Today, she's going to talk to us about the Ocean Acidification Program at NOAA. And the title of her seminar is Expanding Multidisciplinary Research about the Effects and Solutions to Ocean Climate Change. And this is clearly something that's going to become of interest as we go forward. So Dr. Cooley, please.
Thank you so much, Eileen. Thank you for that nice introduction, and I'm glad to see everybody here today. Right now, I'm going to share my slides, so I'll depend on you to tell me if it goes awry. And then I'm also,
Looks
here we
good.
go. Good, okay, happy to hear it. And then I do not have a great view of everyone, so if anything goes wrong, please holler at me because I won't be able to see your visual cues. Okay, hello everybody. I'm Sarah Cooley. I am director of NOAA's Ocean Acidification Program. I have been at NOAA since late August of this year, so I'm still kind of getting my feet wet on being a member of the federal government. But so far, so good. I have a fantastic program. I have fantastic partners, and it's a program that I've admired for its entire existence. So I'm pleased to tell you a little bit about how we are working on ocean climate change and climate solutions. I also want to say right up at front, at the beginning, that I'm very indebted to Gabby Kitch and Jessica Cross, who are current and former OAP members, respectively, for some of the slides that I'll be showing. So I kind of, sifted together slides from all three of our decks. So I probably don't have to tell any of you that climate change is here. We are seeing impacts on all parts of the globe. The sixth assessment report of the IPCC in the first working group report and that the summary for policymakers really started to look at exactly how much climate change has been observed, things that can be attributed to climate change. And this is just a snapshot of heavy precipitation and drought. And we're seeing increases in most of these phenomena. And it's contributing to really observed changes in weather and climate across everything we know. And so, I put this up because we're generally all thinking about the ocean, and it's very easy for me anyhow, to forget about how deep our understanding is of climate impacts on land where observations have been so long. So thinking about how we got here, we need to look at the emissions situation. And again, this is going to be familiar to pretty much everybody here, where global total net carbon dioxide emissions have just been rising over time. And if we can get to a situation where we are decreasing our emissions, we are going to be getting on a pathway that would limit global warming to 1.5 degrees Celsius. So if this image shows light blue kind of transparency for pathways that offer no or limited overshoot of temperature. And you'll see that we go to net zero emissions, or we need to go to net zero emissions by end of century in most of these pathways to remain at 1.5 degrees C or less. And so when we start thinking about how do you get there, carbon dioxide removal, or CDR, could be considered if emissions overshoot that pathway in the next 30 years. And so another way to think about this is some of the infographics that have been put out around the IPCC report. And they're showing again that, negative emissions are necessary for stabilizing climate change at 1.5 C. And so current policies right now are placing us at continued emissions, but to actually get to 1.5 degrees C, we need to drop those emissions. So following the blue curve, and then using conventional mitigation techniques of renewable energy and energy efficiency. And then the negative emission space is going to be involving carbon removal approaches that are helping offset carbon emissions associated with the hardest to abate technologies. So certain types of manufacturing, plastics production of really critical plastic materials, all of those things might be candidates for, considering how to incorporate carbon removal approaches to our total emissions diet, if you will. One thing to think about, though, is that timing is really everything. The longer it takes to reduce carbon dioxide emissions, the greater the reliance on carbon removal would have to be to achieve climate targets. So you can see here that each of these yellow to red to purple trajectories, like each year, the path to net zero becomes more difficult. And, at the time that this figure was created, which I believe was about 2 years ago, if the world relies only on emissions reductions to limit warming to 1.5, global emissions would need to decrease 14% every year starting that year, which I think, like I said, was maybe 2 or 3 years ago. So we're facing an increasingly steep climb to get to 1.5 degrees C. And I'm sure you've been hearing through some of the news that's happening lately about, where we are as a society. And I think I have those statistics later, so I'll hold back from chatting about those. So a few years ago, in 2023, an organization called the Ocean Panel put together an assessment of ocean-based mitigation options in 2050. And they really only focused on the methods that are ready now. And so there's only 5 methods in the list. So offshore renewable energy, decarbonizing ships, both maritime shipping and cruise-based tourism, conservation and restoration, food from the sea, and then also subseabed carbon dioxide storage. And I know you probably can't see in the fine print because the contrast is terrible on this figure, but at the time, scaling storage of carbon dioxide below the seabed was only judged to be able to contribute 0 to 1 gigaton of carbon dioxide removal per year. And so that was 2 years ago. And then this is another figure from that same report. And I don't want you to digest this whole figure. I know it's impossible, but it's a great figure. And I encourage you to check out that report at your leisure. But what you want to take away here is that most carbon dioxide removal, most marine carbon dioxide removal methods, carbon capture and storage that we see here in the upper right are at extremely early stages of readiness. So they are either at the concept or the prototype stages, which are flagged here with the red and the orange colors. If we look at other aspects of the ocean mitigation portfolio, we can see ocean-based food and ocean-based transport and offshore oil and gas, and most methods in marine conservation and restoration, and some of the ocean-based renewable energy methods are all at an early adoption or mature stage, and they are ready to implement. So this just gives you a snapshot of just how early days it is to consider marine carbon dioxide removal methods as a piece of the mitigation portfolio. Um, when we think about, I think my whole, oh wait, this is weird. Okay, this is one, sorry about that. When we think about the entire global carbon dioxide budget, what's important to think here is look at these purple traces on the bottom. The projected need in 2050 is about 9 gigatons of carbon dioxide per year removed, and up to 17 gigatons by 2100. Now, remember that just a year ago, the ocean panel said, hey, we only have at most 1 gigaton of carbon removal per year potential associated with subseabed carbon dioxide removal. So there's a huge gap related to carbon removal. And if we're looking to ocean methods, we need to be thinking about, what how any of these methods could fit into the portfolio. Um, right now, there's hope that land use change, global carbon dioxide emissions, it's about 5 gigatons of carbon per year emitted. Right now, land-based carbon management only gets us about 2 gigatons of carbon removed per year. So already you can see that like there's a big gap and there's a big need to identify carbon removal methods if we're going to be trying to fit our future into this 1.5 degree carbon warming future. Okay, next time. So there's a lot of interest as a result in looking to the ocean, partly because the ocean already provides us a huge service of taking up a third of the anthropogenic carbon dioxide that's emitted. But also it's a big place. There is a perception among people who don't work in the ocean that there's enough ocean for everyone, and there wouldn't be any spatial conflicts just because it's big. Which is not necessarily the right assumption, but it is increasing people's interest in looking to the ocean for carbon removal. So carbon dioxide drawdown in the ocean happens in two ways. One way is biological and one way is non-biological. This non-biological schematic shows how physical and chemical factors really govern movement, dissolution of carbon dioxide into seawater from the atmosphere. And just a kind of reminder back to beginning chemical oceanography, other factors that govern that exchange of carbon dioxide between the atmosphere and seawater are temperature, wind speed, and then the differential between the atmospheric carbon content and the ocean carbon content. But when carbon dioxide is dissolved in seawater, it is stored as a series of ions as carbonic acid and bicarbonate and carbonate ion, and that helps sort of hide carbon dioxide in seawater in a way that enables a lot more carbon dioxide to dissolve in seawater than other sorts of gases do that don't have that sort of acid-base behavior. The other way that the ocean can help pull carbon dioxide out of the atmosphere is through biological processes. Biological processes, photosynthesis primarily, grabs carbon dioxide into biomass and moves it into the deep sea. That photosynthesis is balanced by respiration, and it's important to remember that this biomass can be respired anywhere in the water column, and it would re-release dissolve carbon dioxide. So if you have a whole lot of biological cycling in the upper ocean, you may not actually get enhanced carbon removal from the upper ocean. You may just get sort of temporary holdings of carbon dioxide in biomass in the upper ocean. And the real trick here is to think about whether any biological methods actually give you more carbon removed than they would otherwise. So this is a figure from the NOAA carbon dioxide removal research strategy that came out a year ago. And I have more information on that in a subsequent slide, I think. But it's important. Oh, actually, this might be from the Fast Track Action Committee. Sorry about that. I should have cited that figure. The major methods that are being discussed right now for marine carbon dioxide removal are ocean alkalinity enhancement, direct ocean capture, artificial downwelling, artificial upwelling, ocean fertilization, and macroalgal cultivation and sinking. And so sometimes people divide these methods up by talking about biological approaches, the ones that are circled in green here, and the non-biological approaches. And here, those are circled in blue. And so that kind of distinction really depends on whether the process that's being induced is enhancing naturally occurring chemistry, so just some of that non-biological chemistry that I talked about, or if it's enhancing biological processes, namely photosynthesis and export of biological material to actually do the carbon capturing function. So there has been a really vigorous and growing federal conversation around carbon dioxide removal and marine carbon dioxide removal. In the last 2 years, from 2022 to very recently, there has been a lot of executive branch actions to really encourage action by all of the federal agencies on carbon removal, carbon or climate change action, mitigation action, and really tying it together with economic benefits. And in 2021, there was an executive order to complete a ocean climate action plan, which came out last year. And then subsequent to that, there was also a United States Ocean Acidification Action Plan. And in all of those major products, the conversation around carbon dioxide removal research has become more clear and how that research intersects with what we're doing in the ocean. So the Ocean Climate Action Plan actually requests greater progress from the agencies on marine carbon dioxide removal research planning and implementation. And then the Ocean Acidification Action Plan also points to the need for marine carbon dioxide removal research. So as this was happening, NOAA was also thinking about how its equities interacted with this emerging question of carbon dioxide removal research. So in 2023, a number of NOAA researchers, more than 60 researchers, got together to really think about all of NOAA's investments and NOAA's skill sets and NOAA's expertise broadly, and how it could contribute to this national need for research on carbon dioxide removal. And so the strategy that came out is actually a really, again, it's a really good read if you like reports, but there's some very helpful graphics in there, and the authors did a great job of really laying out how can NOAA engage here. And so there's four main parts. There's the federal motivation of how do we, why is the nation even interested in thinking about this? Then there's a review of carbon dioxide removal techniques and science. Then there's a look at NOAA's assets that could be leveraged to carry out carbon dioxide removal research, and then a greater vision of what that research would look like at NOAA. And so here are some of the highlights of the report. On the left is a figure that is really very helpful to understand how marine carbon dioxide removal measures kind of measure up to compare with other sorts of carbon removal. So you can see that, alkalinity enhancement, direct ocean capture, things like that are also being considered side by side with soil carbon management or direct air capture, ecosystem recovery. And ecosystem recovery spans both sort of aquatic and coastal ecosystems and terrestrial ecosystems in this. But you can see when you kind of zoom in on this figure that the error bars are enormous. And so that really gives you a clearer sense of just how little we know about the effectiveness of each of these methods and their cost. And the little inset item about NOAA's potential impact, the open circle, the half circle, or the filled circle, really looks at how much engagement NOAA could have to make a difference with understanding any of these methods. And so, really, the only ones that are kind of outside NOAA's wheelhouse are really soil carbon management, afforestation, and reforestation, and then artificial upwelling and downwelling. And then the size of the circle also corresponds to the potential duration of the carbon removed. And then on the right side is a list looking at the key NOAA assets that are considered. How could NOAA be helpful here? NOAA already has extensive observing networks, and not only just the maintenance of the networks, but also tech development to make them better and cheaper and more autonomous. NOAA also is heavily involved in modeling and scaling and projecting future scenarios using carbon removal or not using carbon removal. Environmental impacts. NOAA has longstanding investments on ecosystem monitoring, modeling, and sort of, impacts research on how do different environmental changes affect key ecologically and economically important species. And then also, NOAA has equities in decision support, and this goes to data management, but also the synthetic view of that marine spatial planning offers. And in all of these uh, uh, aspects, all of these investments allow NOAA research and NOAA research initiatives to help dig into the questions that really uh, people have about these methods right now in terms of whether the methods remove carbon from the atmosphere, how fast it removes it from the atmosphere, how long carbon is removed for, and how ready they are. And then there's questions about how much would they cost, energy costs, sustainability, and then side effects too are really important. Environmental outcomes, justice, competing uses. And so the report goes into a little bit more detail about, which NOAA line offices or assets might be really helpful and applicable here. In addition to that, um, in uh, in the FY 2023 portfolio, using Inflation Reduction Act funding as well as funding provided by all of the entities you see on this screen, NOAA was able to offer an extramural funding opportunity to explore various aspects of marine carbon dioxide removal. And so this activity leveraged the National Oceanographic Partnership Program. And the real hallmark of the NOP program is that partnerships are really required between federal agencies, academic researchers, and industries. And so the way that this particular call was written, 2 out of 3 of those groups really had to be involved. So actually, my mistake. It was researchers, academic and federal researchers, industry, and nonprofits were the 3 groups that needed to be represented. 2 of 3 had to be represented in every grant. Then what we find when we look at the funded projects, there's a variety of priorities that were outlined in this research, this federal funding opportunity that were addressed. And this is a lot to take in, but it's worth just noting how how many priorities were called out in the funding opportunity. Anything from co-benefits to methods development to whether or not it helps resolve some of the questions outlined in the National Academy's report. That's number 6. And then, are any of these activities participating in or helping with community building and helping engage various publics in the decision making around these technologies? And it's really a wide ranging array of insights that we're going to be gaining And these projects are, oh, I should have said how much money went out the door. It was $24.3 million, and it was 17 projects. Most of those projects are funded on the 3 to 4 year timeline. And so we expect to be starting to hear conclusions from those projects in the next year or two. And so, in addition to this, transformative amount of money that the federal government and philanthropic partners invested in research, it's important to realize that private industry is really moving forward globally. There's a number of US based companies that have been operating either in the United States or abroad. There are efforts in Halifax, Canada, in China, and in Australia too. So, private industry is very enthusiastic about researching all of these methods. And excuse me. And it is worth kind of noting there are, as of a few days ago, there are a number of field trials that are being either planned or begun in all over the world related to either some of this industry excitement that I'm talking about or some of the publicly funded activities in the US, EU, Australia, and other countries. So one of the things that is important for me to explain here is a lot of the NOAA and the federal government based activities around marine carbon dioxide removal research have been based in my program, the Ocean Acidification Program. And the logic behind that has to do with the fact that our research approach is a very transdisciplinary approach. We have always looked into ocean acidification, really exploring three, we call it three aspects or three lobes of the trifecta. So we're looking at the environmental piece, which is, the more straightforward ocean acidification monitoring and modeling. That might be what you think about when you think about ocean acidification research. There's a buoy, we're getting, continuous data from the buoy. But we're also investing in research to understand the biological response and ecosystem models, using ecosystem models and laboratory studies about how economically and ecologically important species respond to drivers like acidification. And then in the third piece of the way that we do work, we're also looking at the human dimensions of it all. We're looking at how adaptation strategies can be developed. We're looking at potential socioeconomic impacts, and we're engaging in education and outreach to really understand what kind of ocean information needs various publics have. So in that way, having this sort of very broad-based approach, having marine carbon dioxide removal join our portfolio, it joins all of these other sort of ways of knowing about the carbon dioxide or dissolved carbon dioxide system in the ocean and carbon cycling in general. And it also leverages all of the partners that we have and develop. So in order to achieve our mission, our program leverages our resources and funding to the maximum possible extent. We always giggle that every dollar that comes into our program probably squeals because we really stretch it to its nth degree. We are a relatively small program, but we have been very, very thoughtful about creating partnerships with across NOAA, and this is a very NOAA focused slide, so you can see how OAP touches other entities across NOAA. But then also what's important probably for your point of view is our extramural partners. We partner with regional associations of the IUS, the what is it, International Ocean Observing System, cooperative institutes, universities, state and federal agencies, private industry, NGOs. And so we think of our audiences as being incredibly broad. There are, certainly we are working to serve the science community, researchers, data managers. We're also working to serve industry members. And again, this list is very ocean acidification focused, but we could update this industry members pool to also include MCDR startups, industries that have an interest in how marine CDR might unfold. And then we also are serving decision makers of all levels, and certainly science educators and communicators, and last but very much not least, the public. So those are some of the reasons why marine CDR research has kind of found a home in the ocean acidification program, because of the way that we look at carbon cycle science as a continuum from change in the water to outcomes for human communities. Okay, changing gears a little bit. I'm going to mention a little bit the Fast Track Action Committee report. So the United States government put together a Fast Track Action Committee, and it completed and released its national strategy on marine carbon dioxide removal research, and released it just a few days ago in November of this month. And NOAA was a co-chair of this report, along with the White House Office of Science, Technology, and Policy. And really what this document does, it provides a real roadmap of what kind of research needs to be undertaken in the future around marine carbon dioxide removal, and how agencies can work together on this. There's 6 objectives that really shape the report findings. And they really relate to things that feel, as a scientist, like common sense about beginning any new research area. So the goals are to promote responsible research that minimizes risk and involves communities. We want to strengthen interdisciplinary research areas. We want to advance measurement, monitoring, reporting, and verification of marine CDR and how research results are shared. And I'll just pause here for a minute to say that MMRV is basically the yardstick or the baseline that we need to use to understand whether any carbon removal from the atmosphere has happened. MMRV is really critical to understand additionality and durability of the removal that any of these methods might create. And so that's, who's going to be creating that yardstick? Very often it is public entities that do that. The 4th objective is really to prioritize research towards most promising approaches, and then really looking at whether marine CDR research is efficiently and effectively permitted, and then also promoting coordination across different sectors and communities. So that's the charge that the federal science agencies have received from the federal government. And now at this point, there is an interagency working group that's just spinning up. We have not had a full count of members join yet, and we have not had a full plan of what we'll be working on. But a number of the topics that the FTAC report spells out as priority research areas are probably going to be things that we're going to take up in the short run. So I encourage you to take a peek at that. It's brand new. And if you have interest in, if you're going to be at AGU, there's going to be a town hall where we want to hear from the science community about what matters to you all when this federal coordination of marine carbon dioxide removal research goes forward. So one thing that we need to know is, where are we on our understanding? On the one hand, there's a lot that's known about marine carbon dioxide removal. There's a lot known about the technical readiness of many of these methods. We're starting to know more about how efficacious they are, how effective they are in terms of their carbon uptake or the durability of the storage that they might create, how scalable they are. Is this something that could operate in a small waterway, or is this something that needs to be a basin scale activity? There's some early information about cost estimates, and there's also some understanding of basic policy implications in terms of, well, all of these policies, all of these permit rules are in place to do research in this particular area. Uh, you know, uh, a practitioner must secure permits to operate in the space. So there's some very basic understanding of policy implications. We have a long way to go in a lot of the areas too, though. So additionality is something I've mentioned a few times. Additionality is making sure that the carbon that's removed is additional to what would happen via natural methods. So it's really, have you made a difference with your carbon removal in the carbon cycle? Another piece that we really need to know more about is verification. As I mentioned, that's really the baseline of like, what is the carbon cycle doing right now? What is normal? What is baseline conditions? And what so that we can measure any variation of the carbon cycle against that backdrop. We also need to know a lot about ecosystem interactions of any of these methods with our existing ocean systems. We need to understand feedbacks in nature. Beyond just the ecosystem scale, there may be chemical system feedbacks, there may be physical system feedbacks. We need to understand social responses and social perceptions to any of these methods. And then there's a lot to be understood about the sort of macro and systemic scale things, like how do we share risks and benefits equitably of doing any of these methods. Even researching them at a larger scale requires us to think about risk and benefit sharing. There's absolutely macroeconomic implications and probably microeconomic ones too. And then just, thinking about carbon removal and climate intervention in general really puts us in a space of needing to think about intergenerational ethics too. There's some very interesting work done by environmental ethicists to think about is it right to intervene with the climate, or is it wrong to intervene with the climate? It's a fascinating area that I think we'll be hearing a lot more about. So it wouldn't be a talk from a government representative if I didn't talk about all the great partnerships we have. And so I just have to toot our horn a little bit and share that we have some new focused partnerships about marine carbon dioxide removal with a number of entities. So first of all, there's this interagency working group that I spoke about that's just emerging. We're just figuring out what agencies want to be involved and how they want to be involved. We have a close partnership with the White House Subcommittee on Ocean Science and Technology. We have a formal partnership with the Department of Energy, and we have a very exciting partnership that is to be announced tomorrow. But unfortunately, I have to keep that under embargo because we're very excited. But watch this space. So in general, I just want to conclude with a couple of thoughts. Climate mitigation absolutely requires a portfolio approach. We know that there are methods to simply reduce emissions. These are things that we have been hearing about for decades. They can be very hard to implement because these methods interact with questions of scale or with obstacles that are, emerging from a different sector. For example, an engineered strategy may interact with some obstacle emerging from the social sector. And those are some really interesting and thorny problems to work out. There's also these areas of attending to climate mitigation that work on increasing carbon uptake. So we have these established opportunities, including nature-based solutions. Additional opportunities include continuing to broaden those nature-based solutions. But these technological approaches, and then this list is a little bit short because it's only from the Fifth National Climate Assessment, and it does not talk about the potential carbon removal methods that are coming online. But some of these carbon removing activities are also in that sort of bucket of increasing carbon uptake. There's certainly a lot of research still needed about pros and cons and interactions. And, I was trying to find a nice graphic that summarized the idea of co-benefits and interactions between any climate um, action and the other sorts of systems, biodiversity, the natural system, human social systems that that we know about. And really, I kind of came up empty when it came to an ocean image. But this terrestrially focused image, really thinking about health and climate, is worth thinking about because it's very relatable. These are things that we've thought about in our everyday lives, as well as, very common conversation within our communities. We have a much better handle on pros and cons and interactions for climate measures when it comes to terrestrial actions. And we're starting to get a better picture for some ocean based mitigation actions, especially actions that do not include carbon removal. So that goes back to the things that I ran through with the ocean panel's findings. So we know that making alterations of ocean related maritime shipping that could really help. We know that renewable energy using marine energy, either wind or tidal or heat, we're knowing a lot more about the pros and cons and interactions of those. But when it comes to carbon removal, we still just don't know. And so I'm going to wrap with this idea of, talking about how the foundation has been laid for examining how marine carbon dioxide removal might contribute to um, the climate action portfolio. But because most of these methods, as you'll see in this figure that's to the right, are at a pretty early level of readiness and not ready to move on to implementation, we still need really intense multidisciplinary engagement. We absolutely need thinkers from industry, from research institutions and from nonprofits to kind of put their heads together and say, well, what do we need to know? What did our decision makers need to know? We need multiple agencies. We're starting to have that in the United States. We need multiple disciplines, and we're starting to have that too. But this is my appeal to you as researchers, and maybe there's some early career folks in the room too. We need multiple disciplines. And so we need to really continue to engage people outside of the traditionally sort of ocean chemistry or ocean carbon cycle science space to start to understand how any of these methods might engage and interact with other things we know a lot about. So I'll stop there and I'll thank you so much for your attention. My email address is simple. It's sarah.cooley@noaa.gov. So I encourage you to get in touch if you'd like to have further chat.